Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1 and we would like to present about solving compound cylinder problem using gas elimination method. Okay, let's start with problem statement. In the compound cylinder of this project, the internal radius of the inner cylinder is 5 inch, while the outer radius is 6.5 inch. The outer cylinder has internal radius and outer radius for 6.5 inch and 8 inch respectively. The question is to determine the maximum stress for the compound cylinder that have 6.5 inch on the internal radius of the outer cylinder. The stress, inner radius of outer cylinder C and total stress of the compound cylinder are given through equation below. Okay, now we proceed with the objective of the project. The first objective is to apply the idea and strategy for a mathematical technique to direct conditions given. And the second one is to determine the pressure of the inner part of the outer cylinder using gas elimination.
The principle of the stress cylinder. In a faulty body in which the internal force acts, stress is a measure of the average amount of force per unit area of surface. The force applied on the cylinder pipe wall by the pressure diffusion finally leads to loop the pressure in a straight closed pipe. If the pipe has a flat end cover, the static pressure force will cause the axis to be perpendicular to the same pipe wall. The value of the shrinkage pressure setup owing to known amount of the interface can be calculated as the standard compound cylinder treatment, each component cylinder being considered separately subject to shrinkage pressure.
Assalamualaikum, my name is Adilia. Today I'm going to explain about the calculation. Okay, the first step, we have to rewrite the equation into the metric form. The second step is the numbers in row 1 have to divide by 0.01. For step 3, all the numbers for row 1 will be multiplied by 6.5 and then the answer will plus with row number 3. Okay, the next step is the numbers from row number 2 will be divided by negative 0.015. For step number 5, the numbers in row number 1 will be added with row number 2 that multiply by 2 and then the number in row number 3 will add with row number 2 that multiply with 12.99. For step number 6, all the numbers in row number 3 will be divided by 10.83. Next, the number in row number 3 will be multiplied by 2 over 3 and subtract from row number 1. The numbers in row number 3 will multiply by 1 over 3 and then subtract from row number 2. The last one is the number in row number 3 multiplied by 0.025 and then subtract it from row number 4. Next, all the number in row number 4 will be divided by 19489 over 108300. Next, all the number in row number 4 multiplied by 25996 over 3249 and then add with row number 1. And then all the numbers in row number 4 multiplied by 12998 over 3249 and then add with row number 2. And then all the numbers in row number 4 multiplied by 8662 divided by 1083 and then plus with number row number 2. Lastly, we have to recheck the answer. Okay, and then we have to use the formula stress for cylinder. We use C3 and C4, which is 0.6222 and 0.5278. By using the formula stress, we get 2.695 times 10 power of 7 psi. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and a very good day to those who are watching this video. My name is Ahmad Aizat Putra bin Sulaiman and I'm going to present the discussion part. Solving linear equation is a typical application that is used in lots of fields, where for our project we utilize the Gauss elimination to determine the value that is needed to compute the maximum stress on the inside radius of the outer cylinder. By using this method, we can alter the matrix into the lower left corner is filled with zeros. This is called the row of echelon. After that happen, we can do the substitution operation where we can obtain the value of C1, C2, C3 and C4, where C3 is C4 is very important, since we use the value of C3 and C4 in the formula to determine the maximum stress. After using this method, we can see that it is very convenient, especially since our problem uses a linear equation. So that's all from me. Thank you.
I will present to you the conclusion of our project. We managed to find solution for the stress of n outer cylinders inside radius can be calculated using a numerical method known as the Gauss elimination method. From that, we learn how to solve the calculation of application in the civil engineering field that we choose the compound cylinder problem using Gauss elimination method. After the calculation, we suggest to ensure that the structure can withstand higher pressure, the structure radius must be higher than what the maximum stress it provides. From that, the failure can be avoided. Finally, this calculation demonstrated how important numerical methods in everyday life, especially engineers, are those who work in the field of engineering. Thank you.